Hello friends. Now we are discussing a problem related to Newtons Raphson method. So the question is like that: using Newtons Raphson method, find the real root of the equation 3x equals to cos x plus 1 correct to 4 decimal places. So correct to 4 decimal places means we will use Newtons Raphson method, and in consecutive two steps up to 4 decimal places, the answer of the 4 decimal places should be equal. Then we can say the answer will come up to 4 decimal places. So as we proceed the problem, it will be clear to all of you. Okay, so here we start. So here, as we see, the function is the function fx is 3x minus cos x minus 1, because the equation is 3x equals to cos x plus 1. So we can say the function is 3x minus cos x minus 1. Okay, though so this is the function. Okay, so as we see, the function here is a mixed function. This is algebraic and this is trigonometrical. So one thing we should remember when we find the root of the equations, because in the initial step we will put a integer. Okay, so when we will calculate using the calculator. So one thing we should remember, as here this is cos x is a trigonometrical function, we have to in the mode of the calculator should be in the radian mode. The mode of the calculator should be radian mode, because otherwise the answer will not come properly. Whenever the function will be a trigonometrical function, we should remember in the calculator the mode should be in the radian mode. Okay, so in this case, first we have to check in from 0. Suppose here we have to check x, where if we put x equals to 0, then definitely this will be 3 into 0 minus cos of 0 minus 1. As we know, the cos of 0 equals to minus 1. So 3 into 0. So here we write f of 0 equals to 3 into 0 minus cos of 0 minus 1. So definitely it will come minus 2. This is 0, this is minus 1 equals to minus 2. So that is equals to negative. So here we find that f of 0 is the negative. The answer is minus 2. That means this is negative. Now, so the procedure is always we can start from 0. So here f of 0 is negative. So in the next integer is 1. So let's check what the f of 1. So as I say that the mode should be in the radian, so in the calculator, if we put in the radian mode and cos of 1, so definitely here the answer will come 3 into 1 minus cos of 1 minus of 1. Okay, if we put in the calculator, the answer will come, we just check over here, 1.4597. so that is positive. Now see, we get f of 0 equals to minus 2, that is negative, and f of 1 is 1.4597. that means this is positive. So definitely we can say the function is continuous. So definitely there is a root lies between these two points, that means 0 and 1, because we get f of 0 equals to negative and f of 1 is positive. So and the function is a continuous, so definitely in this, between this 0 and 1, there must be a root, isn't it? Okay, now we choose, suppose any point between this 0 and 1. Let we choose the root, say x0, and we choose x0 equals to suppose 0.6. You can choose any point between 0 and 1. Okay, so it is always convenient, the midpoint of the two roots 0 and 1, it may be 0.5, but we take here x0 equals to 0.6. okay, and this is very important part of the fast how we proceed. Okay, here we choose x0 equals to 0.6. now we will use the Newtons Raphson method. So as we know, the Newtons Raphson method equals to xn plus 1 equals to xn minus f of xn divided by f dash xn. Now we put the function. As we know, the function is f of x equals to 3x minus cos x minus 1. So we just put over here. So f of xn definitely will be 3 of xn minus cos of xn minus 1 divided by fx is 3x minus cos x minus 1. So definitely what will be f dash x? F dash x equals to 3 plus sin x. Fx equals to 3x minus cos x minus 1. So f dash x, we just derivative this function, we will do the derivative, that will come 3 plus sin x. So directly we put over here, so f dash xn will be 3 plus sin of xn. Okay, now we proceed the next step. Here in the xn will be multiplied in the denominator part over here, so that will come 3 of xn plus xn into sin of xn minus 3xn minus plus cos of xn plus 1 divided by 3 plus sin of xn. I will just proceed, and here 3xn and 3xn, it will minimize and it will come xn sin of xn plus cos of xn plus 1 divided by 3 plus sine of xn. Now we directly put x 0. Here we will put x 0. In the left hand part is x of n plus 1. So we will find x of 1. That means x on 1 means we have to put n equals to 0 over here. That means x of 0 plus 1, that is equals to x1. That means we put n equals to 0 over here. That is x0 sine of x0 plus cos of x0 plus 1 divided by 3 plus sine of x0. And we choose over here x0 equals to 0.6. So directly we put, that is 0.6 sine of 0.6 plus cos of 0.6 plus 1 divided by 3 plus sine of 0.6. So one thing we should remember always, as I said earlier, in the calculator the mode should be in the radian, because whenever we see there is a trigonometrical function, it is very convenient that the mode should be in the radian mode. And after calculating, the answer will come 0.6071. This is the x1. Okay, so here we find x1 equals to 0.6071. Now in the next step we put n equals to 1. That means on the left hand side this is x2, in the right hand side it will come x1 sine of x1 plus cos of x1 plus 1 divided by 3 plus sine of x1. So we get x1 over here 0.6071. So directly we just put 0.6071 sine of 0.6071 plus cos of 0.6071 plus 1 divided by 3 plus sine of 0.6071. And after calculating we will get, the answer will come 0.6071. So as you see, in the first step x1 is 0.6071, and in the second step also the root, that means x2 is 0.6071. So we can say up to 4 decimal answer is 0. That's why the root is 0.6071 up to 4 decimal. Okay friends, now the next problem is very important. This type of problem will come the next problem is a little bit of different types. Suppose the question is like that, find the value of I'm giving 2 or 3 types of examples. Suppose find the value of root over square root of 12, or cube root of 17, or like that, any kind of cube root of 19, like that. So how we will get the value of root over 12, or cube root of 17, or cube root of 19? Just we do just only one problem, but the remaining will be the procedure will be the same. So how will we find the value of, suppose we consider the first problem, root over square root of 12. So we can say let x equals to square root of 12. So definitely we can say the x square is equals to 12, and x square minus 12 equals to 0. That means here the function is x square minus 12. In the second case also same procedure will be the same. We can say let x equals to cube root of 17. That means we can say x cube equals to 17. That means x cube minus 17 equals to 0. In the third case, we can say let x equals to cube root of 19. Definitely x cube equals to 19. So x cube minus 19 equals to 0. So in the first case, function is the f, x square minus 12. In the second case, function is x cube minus 17. In the third case, the function is x cube minus 19. Now we just proceed for the first case. Remaining in the same procedure will be the same. So here the main tactics is how to convert the function root 12 in case of cube root of 17. It may be these types of any types of like that. Okay, so we just proceed for the first case. So here the function is x square minus 12 fx f of x equals to x square minus 12. So as we see in the earlier step or earlier problem, first we have to choose whether the function is for a particular coordinate or point. The function we have to choose for a particular positive number and for a negative number. Now we have to check sequentially. If we check f of 0, this will be negative, f of 1 this will be negative, f of 2 this will be negative, and f of 3 this will be negative. So f of 3, the value will come 3 square minus 12, that is 9 minus 12, that is equals to minus 3, that is negative. And f of 4 equals to 4 square minus 12, that is equals to 4, that is positive. So definitely we can say the root lies between 3 and 4. So the root lies between 3 and 4. Now we take let x0 equals to the midpoint of 3 and 4, just 3.5. Okay. Now we just use the Newtons Raphson method. As we know, the Newtons Raphson method equals to xn plus 1 equals to xn minus f of xn divided by f dash xn. So here the function is xn minus xs xn square minus 12 divided by 2 of xn. Okay, and directly you can write this will be the half of xn plus 12 by x of n. Okay, so as you choose the x0 over here equals to 3.5. now x1, if you put n equals to 0, that means x of 0 plus 1, that is equals to x1 equals to half of x0 plus 12 by x0. And if you put over here x0 equals to 3.5 plus 12 by 3.5, the answer will come equals to 3.4643. In the second case, we will put n equals to 1, that means this will be n x1 plus 1, that means x2, and the value will be half of, this will be x1 plus 12 by x1. And if we put x1 the value of 3 point, that means half of 3.4643 plus 12 by 3.4643, the answer will come using calculator 3.4643. so here we will see the x1 is 3.4643, and in the next step x2 is also 3.4643. so up to 4th decimal the answer is, so up to 4th decimal, the value of square root of 12 equals to 3.46. Sorry, here we just do a mistake. Here x, the answer will come up to 4641. Okay, so we can say the answer is 3.46 because we have to find the answer. If we want to find the answer up to 4th decimal, the answer will not come. Are you getting the logic? Because consecutive in the 2 steps up to 3 decimal the answer is same, that means 3.464, but in the up to 4th decimal here is a 3 and 1. so if we, the question is like that, up to, if we want to find up to 4th decimal answer, we have to proceed another step. But here we can say up to 3 decimal answer is, we can say up to 3 decimal the value of square root of 12 equals to 3.464. Are you getting? 3.464, because the x1 equals to here 3.4643 and x2 is 3.4641. so up to 3 decimal the answer is same. That's why you can say the value of root over 12 is 3.464 up to 3 decimal. Okay, thank you.